a giant cloud in the universe, hundreds of light years away from Earth. Some areas of it are hiding dozens of unborn stars, while others are torn apart by reverberating rays. Space here is filled with deadly ionizing radiation, along with red-hot hydrogen filaments and vortices of matter capable of swallowing whole stars. This is where new stars are born, a stellar nursery near Earth. What is it hiding from us? There are many stellar nurseries scattered throughout the galaxy. Some are modest in size, while others span dozens or even hundreds of light years. These are vast nebulae made of interstellar gas and dust, compressed by gravity. Fascinating. Most of these giant clouds are barely visible in the abyss of space, but some of them can be seen from Earth with the naked eye. One of these structures is the Orion Nebula 1344. Light years away from Earth, it is the central object in the sword of the constellation. Orion, a clear straight line formed by three relatively bright light sources due to its large size and relatively close distance to Earth. This nebula has fascinated scientists since the early days of astronomy, so it is no surprise that this great structure is one of the most thoroughly studied space objects. The Hubble Space Telescope sent back the first images of the Orion Nebula in 1993, where its rich variety of colors was appreciated. Most of the material is red or bluish-purple, while the unusual peripheral regions with bright green lines were revealed through spectral analysis. This phenomenon has puzzled scientists for a long time because of the radiation they observed did not correspond to any chemical element known at the time. Even a hypothesis was put forward for the existence of a hypothetical element called nebulium, which was thought to be absent on Earth but was widely distributed in space clouds. However, with the advancement of science, it was discovered that the light was emitted by extremely dilute ionized oxygen. This discovery not only explains the strange light of many nebula, but also that of the Sun. At present, at least 3,000 stars have been discovered in the Orion Nebula, along with huge interstellar gas clouds and a large number of protostars. All this great diversity of space objects concentrated in a region about 23 light-years in diameter, where they constantly interact with each other. The total mass of matter concentrated here is about 10,000 times the mass of the Sun, on closer observation of the Orion Nebula. We will notice some clearly defined regions that stand out the most. Among them is the trapezium, also known as Theta 1 Orionis. This is an open cluster of stars about 300,000 years old, consisting of 8 main components, some of which are binary stars, while others have no companions. The 4 brightest and most recognizable star systems in the trapezium are named after Latin letters located close together in a region about 1.55 light-years in diameter. Each of these stars have masses between 15 and 40 times the mass of the Sun, indicating that they are very young and hot. Theta 1 Orionis C is the largest and brightest binary star in the trapezium, and indeed in the entire nebula. The blue-white main sequence star with a mass of about 40 times the Sun. The radius is 8 times that of the Sun. The surface temperature of this star is about 45 to 200 degrees Celsius, and its luminosity is about 250,000 times that of the Sun. The radiation from Theta 1 Orionis C illuminates most of the surrounding nebula. But there is almost no interstellar gas in the region, its immediate vicinity. This is because objects of this class often generate extremely strong stellar winds that push dilute matter away, traveling a few light-years away from the trapezium. We will see another notable system is the Tetra High Orionis. This system consists of 3 gravitationally bound stars located near the Orion bar. A large feature of hot glowing gas, this area has long been impossible to study due to dense dust clouds. But thanks to the James Webb Telescope, more detailed images of this area have been sent back. The first component of Theta 2 Orionis is slightly less massive and not as bright as the largest star in the trapezium. Its surface temperature is around 34.7 degrees C. The second component of the system is 15 times the mass of the Sun and 12,000 times brighter. The third component is 5 times more massive than the Sun, with a temperature reaching nearly 13,700 degrees C. However, it is not only the bright stars that have attracted the attention of researchers. The James Webb Infrared Camera has allowed the discovery of previously unseen objects. Hidden deep in clouds of gas and dust, thanks to telescopes, about 180 celestial bodies, called propites, have been discovered at the center of the Orion Nebula. These are dense and dark protoplanetary disks surrounding stars in the process of forming, one of which is Orion 294-606. About 13 years old, surrounded by a disk of gas and dust, about 300 astronomical units in diameter. Thanks to its position facing Earth, we can observe its structure and size. This star is expected to enter the main sequence phase in a few million years and will be accompanied by a system of many exoplanets and possibly their satellites. The night sky of these future celestial bodies must be a truly magical sight. Imagine a sky sparkling with colors, with the light of countless stars, much closer and brighter than what we see from Earth. Occasionally, giant glowing gas swirls cover half the sky, turns the night into a transparent twilight. If we fly a little further and observe a larger area, we will see that most of the nebula is filled with gas. The central part of the cloud contains ionized hydrogen, strongly absorbs a lot of high-energy radiation from stars. The temperature of this gas can reach 9,700 EC but decreases sharply towards the edges of the area. The contrast in temperature and pressure, as well as the collision of stellar winds, causes the matter in